Welcome to Field Lab Earth, the podcast that's all about past and present advances in the fields of agronomic, crop, soil, and environmental sciences. Today, we'll be talking to Dr. Sophia Becker. Geophysical tools can help boost productivity and cut costs in the field. But, as with all areas of technology, work must be done to ensure smooth and useful implementation. In this episode, Sophia joins me to discuss her work studying opportunities and challenges for geophysical methods. I'm your host, Abby Morrison. Let's talk about science. Hi everyone, welcome to the show. Today we have Sophia Becker with us. Sophia completed her master's and doctorate degrees in natural resources at the University of Nebraska-Lincoln. Her research focuses on advancing geophysical methods of measuring soil properties with a special interest in soil moisture sensing. Sophia just defended her dissertation in the fall of 2025 and is excited to enter the next phase in her career focused on soil and water management. Hello, Sophia. First of all, congratulations on defending your dissertation, and welcome to the show. How are you doing today?
Thank you. Thanks for having me. And doing well. I'm excited to share about this paper.
Wonderful. We are excited to learn about this paper. So, a few key terms that we should probably define before we get too far into this. The first is geophysical methods, and the other is agrogeophysics. So I would love if you could explain what those two terms mean.
Yeah. So geophysical methods is referring to a group of methods used for investigating the Earth that relies on measuring variations in the Earth's physical properties using non-invasive sensing technologies. So some of those physical fields that we can measure variations in include gravitational fields, electromagnetic fields, radiative fields, neutron fields, and seismic. So those are the geophysical methods. And then when we apply that to agriculture, we call that agrogeophysics. So that's using geophysical methods to characterize processes or patterns in the soil that are relevant for agricultural management.
Fantastic. I'm excited for this because some of the things you were listing, I was like, I wouldn't think that would affect agriculture that much, but that's why we do this show, so we can learn. So this is a review paper, which means we're going to learn a lot about many different things today. So I would love to learn more about kind of the scope of this review, as well as why you decided to pursue it.
Yeah. So the scope is focused on applying geophysical methods in agriculture. So it's also focused on methods that are more proximal to the soil. We're not looking at like satellites, and we're not looking at laboratory analysis. We're looking at things that can be done in the field. And then the motivation for this was that we are constantly trying to optimize our agricultural production. And part of that is being able to manage the soil in a way that is taking into account the variations within the field. And traditionally, we get information on the soil variability with soil sampling, but that can be cost prohibitive and just time consuming as well. So geophysical methods have the opportunity to collect data in a way that's faster and a way that can be less expensive. So the goal here was to try to see where the research and adoption is really at in terms of actually using geophysics in agriculture, and understanding how the information is transferred between the research happening, commercialization of technology, and then producers actually adopting the technology.
Sure. So I'm curious, we talk about soil health like a decent amount on this show. So I'm kind of curious where you see, I know this is a bonus question, so sorry to throw one in so early, But what is like the overlap between things like soil health and like agrogeophysics? Like we have our Vadose Zone Journal, which is usually way too deep into like equations and physics for me to understand at all. And then we have like soil health is like a little bit easier for me. Like what is the overlap and how those things connect?
Yeah, well, some of these geophysical methods can sense those soil properties that are related to soil health. So, like, one big thing is the soil organic carbon as in terms of soil health. So that's one area of a special interest in geophysics within agriculture is can we use that to efficiently map or track soil organic carbon storage? Yeah, and it's also related to there's different ways we can measure soil moisture with geophysics too, and so that's related to the like hydraulic functioning of the soil and the soil's ability to hold water and other things like that. So
yeah, that's great. That I think that helps ground this for me a little bit more, which is helpful because anything physics related requires a lot of grounding for me. So, I know that for this research, there was a lot of kind of manual labor to kind of get your results. So I would love to hear more about kind of how you gathered everything for your review and what that process looked like.
Yes, it did involve a lot of manual labor. With looking through the peer-reviewed literature, I looked at 2 different databases and I focused on 7 geophysical methods that I knew were prominent based on previous literature. And so I'm searching for papers that mention the geophysical method, and then they also contain some aspect of mentioning agriculture, mentioning like soil or water, and then also mentioning the aspect of like management or mapping. So altogether, those helped me find studies that were related to using geophysics to manage agricultural fields. And I had to filter those titles and abstracts and even dig into the papers to figure out whether it was really relevant to agriculture or not. Because some of these geophysical methods are applied to a lot of other things as well. So like I wanted to filter out studies that were using ground penetrating radar for archaeological studies. Wanted to filter out studies that were trying to track like contamination at industrial like facilities. But there's some overlap there because some people were using geophysics to track like agricultural contamination from feedlots and stuff like that. So there's a lot of parsing out of what's the method actually being used for. Yeah, and patents were confusing too. They can be very hard to digest. But yeah, so I did a lot of reading through those and trying to figure out what they're actually talking about. But yeah, I learned a lot. Was exposed to a lot of different applications by doing that.
Yeah, well, I'm sure there were benefits to that exposure, but you looked through like a staggering number of articles for this. Do you remember the number?
Let's see. Oh yes, the journal publications, that was 2,200, 682 patents, and then 325 extension publications.
That's wild. Kudos to you on doing that. That's awesome. So there were a few things that you were looking into with this review. So one of them was kind of confirming a hypothesis on kind of when we started talking about these tools in these specific ways and kind of when they showed up on the scene. And then there were kind of 5 areas for challenge and opportunity. So let's start with kind of the timing and the history of these terms and when they showed up, and then we'll move on from there.
Yeah. So we were interested in how knowledge is being transferred between the peer-reviewed literature and patents and extension literature. And the hypothesis was that, first we see the research being done, and that's published in the peer-reviewed papers, and then that knowledge is transferred to the patents, and that's where the technology can be commercialized. And then once the technology is commercially available, then extension agents are communicating about that technology to producers. And we generally did find that was kind of the case where we saw the first mention of agrogeophysics appeared in the peer-reviewed literature in 1986. And then we saw the first appearance in patents in 1991. And then in extension literature, we saw it appear in 1993. So in general, but we didn't really track the specific methods in super detail. And there were some differences in like in the patents. We saw that the most popular method was using visible and near infrared spectroscopy, whereas in the peer-reviewed literature, the most popular methods for the studies were electrical conductivity based methods. And then in extension literature, we didn't really find that much agrogeophysics at all, but we found a little bit of electrical conductivity methods, a little bit of visible and near infrared. So it was interesting to see that trend play out in general.
Sure. So I know you kind of mentioned the pathway to getting into kind of more of a commercial availability, but by and large, I mean, are these tools things that farmers can do on their own? Does it require really specialized equipment that they, or do they have to have someone just come out and do it for them rather than invest in the equipment? I mean, where does that fall?
Mm-hmm. Yeah, generally these methods are requiring more expertise than a farmer can just typically pick up quickly on their own. So one way that producers can use these methods are just through different companies that provide these mapping services. So especially the electrical conductivity mapping is the most available. And then there are some, just a very few companies that have like gamma ray spectroscopy mapping. So yeah, it's not very accessible right now for just anyone to pick up. Also, the equipment is, there's a lot of different methods, but the equipment is fairly expensive, so it's not really something that you're going to just buy for yourself.
Hi everyone, I hope you're enjoying the show. Interested in learning more? Sophia's paper, Geophysical Tools for Agricultural Management, Trends, Challenges, and Opportunities, published in Vadose Zone Journal, is always freely available. If you are a certified crop advisor or certified professional soil scientist, you can take a quiz for continuing education units for this episode, which can be found in our show notes or on certifiedcropadvisor.org. Let's get back to the show. So, the first area for kind of challenge and opportunity was linking soil properties with geophysical signals. So I would love if you could tell us more about what you found out about that.
Yeah, this is kind of the area of most basic research, which is where we're trying to be able to isolate that soil property that we're interested in from the geophysical signal, because geophysical signals are affected by multiple variables in the environment. For instance, like the electrical conductivity measurements are affected by the soil moisture, but also the salinity and the clay content. So these different variables in the soil affect one geophysical signal. And one way that the paper proposes to try to solve this issue of these confounding variables is by doing data fusion, where you combine multiple geophysical signals or data sources. It could include like UAV based data as well, but when you're combining multiple data sources to try to isolate that variable that you're interested in, kind of like if you think of you're trying to like solve an equation with multiple variables, and then if you like add another equation and data source to create a system of equations, then you can solve for those unknowns. But in addition to the data fusion, there's also just some exciting new applications, and on those just specific methods, the electrical resistivity imaging, so that's like electrical resistivity in 2D or 3D, has some cool new studies with things like mapping roots underground, and then the cosmic ray neutron sensor and the gamma ray spectroscopy sensor are really cool ways for isolating the soil water content. So that's just a brief overview of that topic.
Yeah, I like that a lot of these tools are like non-invasive. So if we could find ways to just, hold a device over the soil and be like, this is what it is, instead of having to like take a sample and send it somewhere, like I imagine you'd be able to save a lot as far as like time or, obviously the labor to dig up samples, and being able to, just walk through a field and just beep, beep, beep as you walk along would be great. So I really like that. If we can kind of lock in on like how to do that, is really fun and exciting. Mm-hmm. Which I think leads nicely into our next area, which is then kind of learning how to do this at different scales. So I would love to hear more about that.
Yeah. So something interesting about geophysical methods are that they all have these unique sensing volumes, and an advantage of these sensing volumes is that they're usually going to be larger than that point scale that we take our soil samples at. So they're a little bit more representative, and they can be useful in scaling the data to more of a management scale. But it's also complicated because these sensing volumes are not nailed down for all of these different methods. So, and they can be dependent on field conditions as well, such as like the water content of the ground can affect the area that you're sensing. So that's a challenge, but there's continual work being done on really nailing down what those sensing volumes are, so that we can more integrate them with other measurements in a more informed way. Something else interesting about the concept of scale is that different scaled measurements are basically representing the variation within different sized areas. So it can tell us a little bit about how variable an area is if we compare a really small area measurement with a larger area measurement, and we see that, okay, the measurement from this small area and this large area are really close together. That means this large area probably doesn't have that much variation in it. Whereas if the measurement from the small area versus the big area are quite different, then we know that there's probably a lot more going on in the bigger area. So there's some opportunity to, take into account these differences in heterogeneity between different sensing areas. And I'll say a final application for the scale aspect is using these geophysical measurements for integrating or validating satellite-based measurements, because they're at a larger scale than a point measurement. So there's good potential for being a better way to validate satellite-based measurements.
I really like that because we talk about precision agriculture on the show, and how to kind of work with that interplay between point scale and maybe field scale or whatever. But it's never occurred to me that by comparing just like a couple quick things, you might be able to decide, like, I don't even need the point scale. Like, I don't need to do that extra work in this section because it just doesn't have that much variability. So that was, I like that a lot, to kind of cut out some of that need to even gather that additional data is fantastic. So the third group that you were investigating was improving usability. So tell me about that, please.
Yeah, usability is a huge component of making it possible to actually adopt this geophysics technology. And it brings us to the idea of like human capital and how much human labor needs to go into actually using a technology, and then on the flip side, how much it improves like your perceived quality of life and making things easier. So one really effective component that bridges that gap between the human capital and quality of life is automation. There's a study I cited in the paper that was talking about how producers marked automation as being more attractive than or improving quality of life more than things like the grid soil sampling or different precision technologies. But just the automation is a super valuable component. So that's something that I point out in the paper that should be focused on for usability. Another aspect of the usability is related to the soil sample collection. So that's a big part of labor, and if we can use geophysics to optimize that soil sampling, that is a very usable aspect of geophysics. And then also just integrating with existing platforms in agriculture. So like mounting these sensors on tractors is a way to improve usability, and also just multi-sensor platforms. So designing things that can collect like multiple data streams at once can improve the usability. And then finally, the decision support too is important for actually translating the data into the action step. Is really important for making the technology usable.
Yeah, totally makes sense. If you don't know what to do with the data, then why bother? That's wonderful. So then another thing that is very important to anybody using these technologies is the profitability. And so that was your fourth area for challenge and opportunity. So tell us more about that.
Yeah. So right now there's quite limited evidence for how profitable it actually is to have this geophysical data collected and then use it to prescribe different management. And it's really important to actually follow that the geophysical data all the way through the process to see like is yield actually being improved, or are inputs actually being reduced, and how much money does that save the producer. So there's some examples of doing like long-term simulations of this, so I think that's important. And another complicating factor is that the plant or the crop response to inputs is also like dependent on climate, and so there's all these unknown variability, that can affect the profitability of using geophysics. So that's where the long-term simulations can be helpful in providing recommendations on how profitable something is. And another aspect of that is just focusing on these some niche applications that have more potential to be profitable. So one of those is water scarce environments has more potential for agrogeophysics to really be profitable, just with the irrigation management and water savings potential there. And another interesting application that came up in the review was for pest management, doing texture mapping for pest management, and the money that can be saved on nematicides if you know where your field needs it and where it doesn't. So I found that to be interesting. This is another aspect related to both the usability and the profitability, is just making sure that the measurements are accurate once they're at the point of being commercialized, because there was a study that I came across that found that some commercialized Vis-NIR and I think gamma ray spectroscopy service, they evaluated it and found that it wasn't accurate. So that would be a huge hit to the usability and the trustworthiness of geophysics if we don't do the research on the front end to really understand the uncertainty and how accurate the predictions are.
Yeah, totally. I'm also surprised to find out that there's like pest management uses with that. I wouldn't have expected that. This is delightful. So tracking soil organic carbon was your last category. So tell me more about that.
Yeah. So this is a pertinent area for agrogeophysics, and there's a few different aspects. One is the soil sampling aspect. So typically the soil organic carbon tracking is done with soil sampling, and one use for the geophysics could be to direct that soil sampling and optimize it, and may perhaps reduce the number of soil samples that you need in the field. And then another application for the geophysics is using the geophysics itself for the soil organic carbon detection or monitoring. And the method that really came out on top as looking most promising in the review was the visible and near infrared spectroscopy, especially because there's some profiling probes that have been developed, so you can actually get the visible and near infrared measurement at multiple depths in the soil. And combining that with bulk density estimates allows the calculation of the soil organic carbon stock. So that's probably the most promising looking method for the soil organic carbon. There's also some research on gamma ray spectroscopy for the soil organic carbon. It's been mostly done with peat mapping in Ireland, and there's potential to develop that more as well for the soil organic carbon.
That's awesome. I love that. So it feels like in a lot of ways there's a lot of research yet to be done to kind of connect these different pieces to get them advanced to a stage where they're properly calibrated and ready to go to be used more frequently by whether that's the companies or farmers or, what have you. So in your ideal conception of like the future of agrogeophysics, like what does that look like? What do you see as the biggest? I mean, we've talked about very specific opportunities, but like what are the biggest areas where you could see this like really helping people and really supplementing the science and agriculture at large?
Yeah, that's a good question. I think I see it as a way of quickly gathering information about field variability and especially just designing management zones, which electrical conductivity based methods do a pretty good job of already. But I think the idealized version of the agrogeophysics technology would be being able to quickly map a whole field with a platform of multiple sensors, and then be able to take that and be like, we know what the texture is, what the pH is, what the organic matter is, with needing very minimal calibration samples. So I think that's kind of the idealistic like vision, which would allow just more precision management where it's profitable. I think that's the other idealized part, is like having this automated decision support and analysis of how uncertain is this and how much would it profit you to do this. So
yeah, I love that, because I'm consistently floored by how complex farming is. And I think, at least this is how I felt before I got into all this, is I think that the average non-agriculture adjacent person like would never guess how complicated it is, and it's like, I'll just put stuff in the ground and water it and maybe get some food and it'll be fine. But it is so complicated. And so I think being able to provide farmers with like data to back up their decisions, to give them confidence that like they're making the right decisions, that they're just being able to approach decisions with confidence is massive. And any way that we can support farmers and make things easier for them, reduce the uncertainty when you're in a field, pun I guess intended, that is just rife with all the uncertainty of like weather or natural disaster, or like there's so many things that just inherently bake uncertainty into it, that being able to reduce that for them seems incredible. So to that point, it seems like there's a lot of room for growth and future research to kind of reach that idealized stage. So what is on the immediate horizon? Where are we going?
Yeah. As far as the field as a whole, are you asking?
Yeah, as a whole or related to these specific areas, anything.
Yeah, I think that's a good question. I think the trends in the publications show that like the field is, people are still interested in it, and it's growing at a fairly steady pace. So I just expect to see more research kind of in all of these areas. I think we kind of need more research at all aspects of that continuum, from like the basic figuring out how to isolate the soil property from the geophysical signals, all the way to the like automation and decision support. I think we need people to be working at solving the issues at all of those different points. Yeah.
Sure. Yeah, totally. Well, other researchers who are interested in joining Sophia, there's much work to be done. To which we have 3 questions left. The first one is if people would like to learn more about any of the things you've been talking about today, where can they go?
Yeah. Well, one place you can go is to the Vadose Zone Journal, and there is a special section on agrogeophysics that has more like some case studies on these specific examples of the geophysics being applied in agriculture. I think the paper that kind of summarizes the special section is called The Rise of Agrogeophysics by I think Sarah Gary is the lead author on that. And you can also just Google search and see what like mapping services are around in your area, and try to see if there's any like electrical conductivity service or something like that in your area.
Sure. Great. We will add links to all of those in our show notes. So that is great advice for people looking to learn more. Then next step, if people want to get involved with any of this, maybe look at using it on their farms or get involved with the research, what can they do?
Yeah, I guess maybe I already said that you could like search for mapping services in your area. One of the most common services is the Varus Technologies electrical conductivity mapping, so you could see if there's any Varus providers in your area. Yeah, and then just to stay informed, sometimes I like to set up, like Google Scholar search alerts for different topics. So this is definitely an evolving field that you can just, try to stay informed on what's happening.
Yeah, totally. Yeah. Hopefully you don't need to scan through, 2,000 plus materials to stay up on things. Those alerts sound like a great idea. We'll also have contact information for you if people want to reach out. So, final question then. What is one fun fact that listeners would not know about you if all they had was your research?
Yeah. Something fun about me is that I love to run. I started running as a kid, and then I ran track and cross country at a small college. I went to Wheaton College in Illinois, and I'm still keeping it up. I ran my first half marathon this fall, and it's just one of my passions. I love that I get to be outside, and I think the perseverance in running transfers to perseverance in research. So yeah.
Yeah, definitely. I can see a lot of kind of analogies that could apply there. So this has been a wonderful conversation. I so appreciate not only your work in kind of digging through and sorting all those articles to do the review, but also all the future work as you move forward in your career that you will do. So thank you for your time and being on the show.
Thanks for having me, Abby. This was fun.
Thank you for listening to Field Lab Earth. More information can be found in the description below. Thank you.